Hello everyone and welcome to another OrCAD video. We're going to keep this one short because in this one we're going to talk about your layer stackup or your cross section and how to manage your impedance control in the board. Alright, so first let's talk about your layer stackups or your cross section. So to access the cross section in your board, you're going to go into Tools and select Cross Section. Now the cross-section editor is kind of your one-stop shop for everything that has to do with the stackup for your PCB. If you look here, we have a nice little table where you can use this scroll bar to go from the left side to the right. And we cover everything in this table from the types of layers, their thickness, to what physical material it is, even to some signal integrity parameters, such as, if you have a certain width of trace on the layer, what is the impedance estimated to be? And you can even include additional factors such as the etch factor and a lot of different options that basically allow you to really control your cross section and the behavior of the signals on those different layers. Now, I have here open a board which has some routing in it. It doesn't have a lot of controlled impedance traces. However, let's first talk about how you can control the layer stackup of your design. So here we have 4 layers already defined. We have the top layer, the ground layer, which is layer 2, the power layer, and the bottom layer, which is layer 4. If we want to add an additional layer, simply right-click on one of these and select Add Layer Pair below. Now the reason we say Add Layer Pair is because we want to add both a conductor and a dielectric, right? So we want to make sure that all of our conductors are sandwiched between 2 dielectrics. And if we were to just select Add Layer, we'd get this huge little list here, which I generally don't recommend using, but you can then add, for example, just a conductor layer. And you want to make sure that you don't forget to then additionally add a dielectric layer. If you click on the layer, let's go ahead and just add another one here. So Add Layer Pair below. We want to make this a 6-layer board. We can call this our inner 1, or actually this would be our inner 2 and inner 3. And here we have these set to conductor layers. And then if you look at this drop down here, you can choose if you want it to be even, for example, a plane layer. Now, in terms of how you route on that layer, just by default, there is no difference between a conductor and a plane layer. However, if you go into Constraint Manager, let's just quickly click OK here. There are some additional options for if we go into the physical realm, nets, all layers. We want, for example, the physical constraint sets by layer, and these can actually be grouped by, for example, your plane layers and your conductor layers if you choose to do so. Here, all layers, and then here we have our conductor layers and our plane layers. So if you want to, for example, create a larger rule which will apply to all plane layers, you can do so. Or a rule which applies to all conductor layers, you can do so as well. It's kind of more of an advanced feature, and I honestly don't see it used very often. But going back to the cross-section editor, if we go to the right side here, you see that we can choose what is the thickness of these layers. So that's important for both calculating the impedance, which we saw on the right side, and also for the 3D visualization of our layer. And also, if you're doing some high-speed routing and are trying to match the signal lengths for propagation delay, and you're including something like the Z-axis delay, for example, if your signal goes from the top layer through a via to the bottom layer, how thick those layers are will impact your total etch length. So making sure that this is correct is important and usually can just be directly copied from whatever stackup is provided by your manufacturer. Likewise, you can choose a material, and if you need to, then you can set the dielectric constant for that material. So by default, for example, FR4, I believe just defaults to 4.5, but if you need to override that, you can go ahead and type in that number here. So as you change this dielectric constant, maybe you even change the width of your traces on that target layer, you'll see that this impedance also changes. Or you can set a target impedance of, for example, 90, and then you will get a width which would allow you to achieve that target impedance of 90. Now keep in mind that your physical and spacing constraints might not allow for that. So just make sure that you look at the difference between those two and make sure that it is actually compatible with your StackUp. So we've gone ahead and pretty much done everything that we can in this cross-section editor. One other thing that you can do is also import and export technology files, which include all of the information for your StackUp. So if you've created a StackUp for a 6-layer board and want to use the same StackUp for another board, rather than re-entering all this information, just export it from this design and import it into that other design, and you're good to go. All right, let's talk about controlled impedance traces. So I have here, I believe one of these traces is a USB signal. If I go into my constraint manager and go into the physical net all layers, here's my differential pair for USB. And if we go to the right here, we have some options for differential pair, which is a type of controlled impedance. Well, you can also simply control the impedance by changing the line width of your trace. And then based on the line width and the distance to the dielectric below and the dielectric constant of the material that you're referencing, or that is used as the return path, you will then have a impedance. But you can set your line width in Constraint Manager. If you have a differential pair, you can set your minimum line spacing, your primary gap, your neck gap, and the tolerance. And the nice thing is that when you use your routing command, the add connect, if you start routing from one of those USB traces, which I am not seeing right now. Okay, I think it's these two right here. Make sure that you set your trace width to auto. So what that will do is it will actually use the constraint value when possible. And then here we also have this option for example, differential pair single trace mode. So if I click on this here, which I know is a differential pair, it will act like a differential pair and allow me to route like it's a differential pair. Or if I click on the diff pair single trace mode, I will then route a single trace, and then you'll notice that it will try to achieve that differential pair. Let's just turn on this layer, make it all red. There we go. So let's delete this trace. There we go. So we already actually have some traces on here, and you'll notice that if we were to, for example, change this trace width of this trace segment to, let's say, 6, then you'll see that we get a DRC, which says that the minimum line width is incorrect, the differential pair minimum gap is incorrect, and let's see what this guy here is. It says differential pair minimum gap is incorrect. So make sure that you use your physical constraints to set things such as, you know, your line width. If you're using differential pairs, the gap that is required between your traces to achieve a differential pair impedance. Or also you can use the electrical rules to set a impedance. For example, let's say the single-ended impedance on each of these is 45. Excuse me, that's the tolerance right there. So 45 and 45. And I turn on this analysis mode here. Oops. Then if we update our DRC, based on your StackUp, which I actually changed before, so it might be incorrect now, we can also then calculate the impedance of each of these traces, again, based on the trace width, based on the layer thickness, the dielectric thickness, the dielectric constant, the etch factor, and then see if we are meeting that target impedance, plus or minus the tolerance. All right, guys, so that was a quick video on the layer stackup and impedance control in OrCAD X. If you have any questions, feel free to drop a comment below, or if you have any suggestions for future videos, please let us know as well. And look forward to seeing you in the next video. Thanks for watching.